Hello class, today I'm going to talk about mesh, generating mesh, refining mesh, how to improve the quality of mesh locally and overall for whole geometry. Let's start with our ANSYS workbench, which is here. Mesh refining is a very important subject which can directly affect the results you are getting. Sometimes results can drastically change. Okay, let's go static structure by dragging it, name it, add material. Let's go to the reference material, general material. This time I'm going to add titanic alloy using this add key. So I have titanic alloy and structure material both here. Let's close the material section, open geometry. Great. First thing is selecting drawing surface. By selecting this, select new sketch plane tool, you can select the surface you want. I want XY surface. So I select XY and for view, front view. Great. Let's go and draw a rectangle here. 50 millimeter for vertical one, and for horizontal I'm going to press tab key to move to horizontal dimension and 100 millimeter for this case. The next step, I would like to use mirroring to decrease the load of drawing work. For that, you need to select and use construction line. As you can see, when I'm moving over this line, there's a triangle over this at the middle of this line, which is showing me the center of the green line. So I can easily select this line at the center and connect it to the other side. Now I'm going to select select tool, select this construction line, right click and select set as mirror line. Now whatever I draw under this line is going to automatically copy over this line or vice versa. What's next plan? I would like to have some cuts, circular cut here and here. But what is the distance of those circles from this line? 20 millimeter would be good. So I'm selecting circle tool here. But I don't want to count here. So what I'm going to do, select Cartesian dimension. And this blue dot is going to show me, I'm going to select the origin of distance I want for drawing this circle. So I said I want to draw a circle 20 millimeter from this point. So I select this point, move it 20 millimeter. Now I can draw what happened? let's repeat it. Cartesian here, 20 millimeter. Now I can draw the circle. Circle is going to have 18 millimeter diameter. And let's turn off the Cartesian dimension. Let's have another cut around here to have stress concentration area. This time it is going to be rectangle. And 40 millimeter from this side. 40. Oh, it didn't work again. Let's repeat. Cartesian. $18 for this dimension and 60 for the other dimension. Now let's edit. Wait for the line to get green and click to delete it. We are done with the sketch part, 2D sketch. Now let's click over pool and have 5 millimeter depth. Five millimeter depths. We are done with this case. We could apply some round here. I select this surface, drag it, and use 5 millimeter round for upper and lower side of this. So stress concentration would be a bit lower. Okay, done with this. Now opening model. Okay, ready. First thing first, let's add the material. As a default, it is structural steel, but this time we selected titanium alloy and we already added to our system. Let's see what type of mesh automatically will be generated as a default. As you can see, very coarse mesh and the result won't be that much accurate. But let's see what is the range of results. And oh, I forget to add the support. So let's have fixed support here and select this line to apply a force, not vector, component at y direction, because I want to be downward, so negative 200 or 5 or 300 Newton. Now it's time to solve it. Stress, yes, we have stress concentration around this part and this part. And some other stresses close to this area. Let's see, when I click mesh, the details here shows a relevance option. Relevance changed from -100 to 100. Currently it's 0. Let's go for -100. What is the effect? Oh, the mesh size is so large and it gives us some error. Let's go to the +100. Now mesh size is much better, kind of uniform, and all over area we have same mesh size, and still it's very rough. Let's add method. Right click over mesh. From insert section, select method. You need to select geometry for this. I select this side and apply this geometry. So geometry is selected. Currently it's automatic and it's a default geometry. You can see here. Let's go and put relevance to 0 to see the differences. So with automatic, let's see what's the difference. This is automatic. And the mesh shape for 2D is like a square or rectangle. 4 different points for each element as a 2D. Let's check it if we convert this automatic to tetrahedron. So tetrahedron means they're going to have triangle shape. Now let's see. So the shape is triangle. Let's change to the other one, hex dominant, and change the shape. This is the case for hex dominant. Still, the size of mesh is very large and we need to have a bit smaller mesh size. How many nodes or mesh we have? You can use this statistics to know how many nodes we have. 821, which is nothing, very small number. To increase that mesh number and the quality of mesh, I'm going to add sizing. Select this surface as a geometry for this, and element size, I'm going to add this number. Let's see. Not that much better, so maybe the number I used wasn't fine enough, so let's go to 1.001. density is much more, and if we solve, we can see that stress reading around the stress concentration area would be much better, much more uniform and smoother, because we have more data to read. And you can see even the data is almost different than the one we saw with the coarse mesh. This is the one we are talking about. When you have a better mesh, quality mesh, the results could be different, and you shouldn't trust for the softwares or for the case you are using the coarse mesh, and those results may not be reliable. As you remember, if you remember, for the previous case we had some stresses around here, and the stress concentration was mainly at this area. But with this new finer mesh, we can see the stress concentration is mainly at the tip of this section, which is totally different. If there was a conflict between these mesh comments or commands or different options, ANSYS automatically is going to select the higher level one. Okay, what's the problem with this mesh? It's uniform for everywhere, which we don't like it. We want to have concentration of mesh or finer mesh for the area we know there's a stress concentration. For the other area we can have larger mesh. So let's use sphere of influence. I'm going to increase a little bit the size of this to 3. So everything would be faster, and we don't need to wait long time for the results. Okay, let's remove this one. When I'm removing the method, it means I'm going to use the automatic one. So having method with automatic, not having method, they are both same. Okay, now I'm going to use sizing, but instead of using element size, I'm going to use sphere of influence. I forget to select the geometry. Okay. Now, what is the option? I can use global coordinate system as a sphere center. Let's use for global system coordinate system as a spheres. Radius 0.02. It will be here. So it is going to cover this area which we have a stress concentration, and a little bit of this area which we may have it. And the element size is going to be 0.02, a little bit finer than the other area. Let's see if we like it or not. Let me remove this, the first sizing. Now to be able to see the effect. Element size 2.1. As you can see, the sphere of influence area has a finer mesh. Okay, we selected the center of that sphere using the global coordinate center. Let's use a point for that. So I'm going to select a point. For example, here, because we knew that there's a stress concentration here. I selected that point. Now I'm going to add this insert sizing. Automatically ANSYS knows, because I already selected that point, it is going to be the center of our sphere of influence. So radius 0.005, not too big. 1, good enough. And the size, let's see if we like this one or not. So as you can see, much finer at this area. Let's select the line for this case. I'm going to select this line to increase the mesh quality area, that area, sizing. And for element size, I'm going to use 1. Let's see. So this line also is improved, and we have much nicer and much more quality mesh here. Let's solve the whole system. Now you can see we have less number of mesh. We just have 12,000, but the quality of the data is much better than the very coarse one. Okay, let's select another option, refinement. For this case, we need to select geometry. I'm selecting not this one. Let's select this part and this part, which we know there is a stress concentration at these areas. So the important surfaces for stress concentration are selected, and I applied the geometry. Refinement has 3 levels, number 1, 2, and 3. Let's go for level 2 and see what's the effect. Currently, it's like this. At the upper section, we have very limited number of mesh, and they are mainly very coarse. Now you can see the stress concentration area are much better, and the quality is much nicer. Let's remove this one and delete. Now update everything and solve the whole system. Let's go and refine to level 3. So the mesh close to these surfaces we selected is going to get much finer. Now let's update and generate the mesh. As you can see, the quality has improved very well. I'm going to get rid of the edge sizing to have a kind of uniform mesh improvement for upper and lower side. Let's zoom this area of interest, and you can see this is the only area we have concentration or stress concentration, and the trouble is happening here. And for the other areas, actually we don't have, but with larger mesh we saw some stress concentration in those areas. Currently the maximum stress is 1.445. If I remove and go for the default mesh, the result is 1.1, and the stress concentration area is these two positions, which is completely wrong. Add refinement for the area of interest. I'm using Control button to select several points here. Let's add these two sections to apply. Refinement level 3. Now let's see. Again, it's totally different. From 1.18, I think, to something else. Amount of stress around this area decreased. The stress about this area increased, but still we have some stress here. Let's select this one. Change the size to see what's the effect. As you can see, the quality is much better, much finer, close to the area of interest, and coarser at the center. This could be much better result. And the number of mesh is 129,000. Let's add another refinement, this time here and here, level 2. It is going to be slower because the number of mesh will be much higher than the previous one. Oh, we reached to the maximum number of the mesh size we can have for academic versions. So refinement level 1. Let's see if this is going to work. Okay, still a lot. Let's get rid of it. Or for geometry, let's now let's see. This seems much better results in comparison with the others. Mesh is refined very well. Deformation is okay. And stress shows the maximum is 5 times 10 power 8 Pascal. And it happens here and a little bit here. Not this area, not at the middle. Thank you very much.